So before we get started, just a couple of quick announcements. There's nothing for you to hand in for lab today. If you were there, you got an A for it. That will change next week. You'll be going to the Dropbox, zipping up your files, one per team. You'll have be signed random partners in lab, one per team. I think I forgot to mention in one of the classes, I have a policy about you have one mess up that can apply to lab and lecture. So if you do miss a lab once, I'm going to let you make it up on your own, hand it in by the due date as usual, only you will be working by yourself. And that will be your one mess up for lab. Then, of course, if you miss another lab, that's an F. The same is true for lecture. If you show up late for an exam, that counts as your one mess up. If you hand in you have to hand in a program a day late. Not infinitely late, but 24 hours late. That will count as your one mess up. Okay, so I know that sometimes stuff happens and you just can't get stuff in on time, so rather than simply saying no mistakes are allowed, that's the policy I've sort of adopted over time, is that you're allowed one mess up. It's really, really annoying, though, when you ask for a second one. So please don't make me say no. The answer is going to be no. Okay? So you do get one freebie. You don't even have to tell me, hand in a program late if you haven't already used your freebie, which I'm going to keep track of in my grade book. If you haven't already used it, I'll take the program late. Okay? That does not mean a week late. That means 24 hours. Okay, so I want to make sure that I'm not sure that I mentioned that in both lab classes. So let's do some Java. So what did we learn so far? Well, everything's got to be inside a class. So just some syntax details. Everything's got to be inside a class, and the main method is where your program is going to start. So in this particular class, all we have is a main method, and that's going to be fairly common. Okay, whatever class you designate as the class that's going to start your program off, usually you don't have much else in there other than the main method. So that main method is going to be creating objects from classes, doing stuff with them, etc. Okay? So that won't always be the case. Every once in a while we might have a main method that has some other stuff in it. But vast majority of cases are going to look like this. Okay, so it doesn't have to be the only method in here. That's just the way you're going to see me to do it frequently. Now, the rest of this stuff in here, we don't really know what all that stuff means yet. So the only thing that's really important for your purposes right now are the fact that it's a public method, which means that anybody can call it, including the operating system. And it's the main method, which means that's where your program starts. So the compiler will complain if you have two classes in your project, both with main methods. Okay? So you'll have to figure out, move one of them out of there, change something. It's got to know exactly where the program is supposed to start. All right, so what I want to do now is start investigating how to write this rational number class. So we can see here that there's some C++ type stuff. I use new to create a new object. I pass some information to the constructor because I want the numerator to be set to 2 and the denominator to be set to 3. So I need to write those variables inside the rational number class. And of course, new returns the memory address of where those variables were located in memory. And then my rn1 will contain the memory address of where that stuff is. Okay? So most everything is going to be pointers in Java. Although technically they're called references, I'll probably use those terms interchangeably. Okay? So let's take a look at the nuts and bolts of that thing. Let's see how we might write this class. All right, well, everything's got to be inside a class. So now we've got our rational number class. And oh, by the way, another detail that we probably won't mention much until much later in the class is you can only have one public class per file. So what you will see me do for them in most cases, but not all, is just have one class per file, whether it's public or not. Okay? We'll talk more about why you might not want to have a public class later. So just get used to the idea of one class per file, and you can't violate that rule. Okay? There's a couple of cases way down the line where we might want to have more than one class in a file. Okay, so here's our rational number class. It's not going to contain a main method because I don't expect the program to start within here. What I'm expecting is people to call the constructor and set up these two variables, the numerator and the denominator, which are primitives. So they're not going to be pointers. So in memory, when I set up, let's draw a picture of what's going on here. So we have RN1 pointing to a location where the numerator is set to 2 and the denominator is set to 3. Okay? And those are not pointers. They actually contain those integers. They might have been pointers. There's nothing wrong with having a class that's, as part of its definition, are other classes. Okay? Which means I'm going to have pointers to other objects. But right now, they're just primitives. Ints and doubles and that kind of stuff, just like in C++, are not pointers. Okay? Okay. Where was I? Down here. Okay, so we're going to make them private. Here's something super annoying. Now, we already see two what are called visibility keywords, public and private. Public, it should be obvious. We want other people to use it, just like we want to be able to create rational numbers from the rational driver class. So we're going to make that class public. And we want the operating system to be able to run rational driver, so we make that class be public. Okay? What you should get used to by default always doing with your the variables that represent the state of the object. So let's just call this stuff, let's see. These are state variables. There's actually a bunch of different things I'm going to call these. You might hear me call them instance variables. You might hear me call them fields. What else? I'll probably think of some more in a few minutes. Okay? This is probably the most important thing we'll do the entire semester, is discuss what these things are meant to do. Okay? So let's go back. So a rational number, what its definition is, it's one integer divided by another. That's the definition of a rational number. So it makes sense that I'm going to create two integers to represent the contents of that rational number. Now they can be anything, but I'm going to have one integer divided by another. Okay, that might be 7 over 1. Hopefully it's not 7 over 0, but one integer divided by another. Okay? Just like for the card that we discussed last time, there's going to be a variable for the suit, there's going to be a variable for the value. Okay? So understanding how to create these things is super duper important. When you're so remember we talked about distributed data. In a non-OO programming language, high-level programming language, you would be passing all the numerators and denominators around. Okay? Instead, we're going to let the individual rational numbers store their contents. Okay? So there's not really anything else that it needs to go in this class, because we pretty much know what a rational number needs to store as far as its state variables. Okay? The term instance variables comes from the fact that when we actually give those variables values, like we did over here in rational driver, we created what's called an instance of that class. In other words, we created an object. Okay? So when you create an object, aka instance, you are specifying what the instance variables need to be. So fields, state variables, instance variables, it's all these really super duper important things, numerator and denominator in this case. Okay? Now, I've got pi written here from the last time I taught the class. Okay? What's going on? Is it already out of calibration again? It was fine when I tested it when I came into the room, but now it seems to be off again. What does that mean? That's the three important concepts for object-oriented programming are polymorphism. We're not ready to talk about that. We're also not ready to talk about inheritance. But we are ready to talk about the most important of the three. If you don't learn anything else, learn encapsulation. Okay? And that's where this private keyword comes in for both of those variables. You're allowed to create rational number objects, so the class is public. But I do not want you to change the contents of numerator and denominator without me checking what you're trying to do first. So if I make these two things public, let's pretend like, you're trying to annoy me on an exam and you decide to make your instance variables be public. Okay? That raises my hackles. So don't do that. If you want me to be in a good mood grading your exam, make sure you don't lose points for that. Okay? Those are some freebies there. So always make them private. I will be less upset if you make it private when it was supposed to be something else in those rare cases than I would be if it's supposed to be private and you make it something else. Okay? So always err on the side of making it be private. In fact, I'd probably even let it slide. If you made it private and it was supposed to be, it was one of those rare cases that it's supposed to be something else. But the vast majority of cases, we want those things to be private. Why? Because back over here in my driver, I do not want the user to be able to do the following thing. Okay? Not good. So what they can do, so the alternative is, let's suppose they really wanted to try to mess me up. And they do something like this. 2-0. Okay? Really important concept. The constructor is public. I have to let my user create the objects. I have to give them the opportunity to put values in for those variables. After that point, I can restrict their access. Okay? Here's the difference. By forcing them to go through a procedure, or in Java, OO language, a method, in this case the constructor, I can check to make sure the values that they gave me are correct, that they're valid for that rational number. Well, if I see a 0 coming in there, we're going to get more sophisticated with error checking later, but right now, if I see a 0 coming in, I'm going to change it to a 1 inside the constructor. I'm going to prevent that 0 ever getting set into the denominator. Okay? However, if I make that variable be public and not private, okay, here we go. They're allowed to directly access it, and they can set it to be any value they want, even stuff that's really going to cause the program to crash. Okay? So please, so encapsulation is restricting access to stuff, and that's the first thing we want to do inside the rational number class, is make sure that the numerator and denominator are protected, so that if anytime the user wants to attempt to change, in fact, we talked about the fact we made rational number immutable. What does that mean again?
Unchangeable.
Okay? You can't, after the constructor runs, there are no methods provided that will let the user change that numerator and denominator. Okay? The only time they can do it is through the constructor. So that's the only time that we have to do error checking. So if we make this object immutable and don't let them change numerator and denominator after the constructor, my life is much simpler. Okay, I don't have to put a bunch of error checking code in other places. Okay? Okay, so you can see in the questions about that. That's super duper important. All right, so who's going to put public for their instance variables on the exam? No one. Good. Okay. You just got some points. It's the third day. You've already got points on the next exam. Okay, so you can see what I did here. The first thing I checked was, if they try to pass me a 0, I'm just going to change it to a 1. Okay? Now, that's not very sophisticated. In fact, it's pretty bad error checking. But it's what we got right now. We'll get a lot more sophisticated later on. Okay? Another thing I have to deal with is I want to be able to handle negative numbers correctly, but I want the denominator, so the numerator to store the sign. What does that mean? Suppose I wanted to set, instead of what I did here with 2/3, let's go back to this code. Suppose I wanted negative 2/3. Okay? That's a perfectly legitimate way for me to put in a negative 2/3, 2 over negative 3. But for convenience sake, I would actually like the negative to be stored in the numerator and make sure that my denominators are always positive. Okay? So how can I do that? Well, 2 over negative 3. If I simply multiply the numerator and denominator by negative 1, I'll be sure that that happens. Okay? So there's nothing wrong with that input. I'm just storing it in a more convenient way for my program. Okay, so if the denominator is less than 0, I multiply both the numerator and the denominator by -1. Okay? Finally, I'm ready to copy those values into their instance variables. And then I run an algorithm to reduce them. Okay, it's all the way at the bottom of the file. It's not super important. Okay? Now, I've got some different types of variables here. So next most important thing. In fact, today's lecture is pretty important. So I'm glad you showed up on a Friday before a 3-day weekend. Okay? Super important. Local variables that you hopefully remember from C++. How long is numerator and denominator? How long are these things going to be around? Oh, come on. Forever? Yeah, they only live, they're local variables. Parameters to a function and anything I declare inside the function are local variables. Okay? They're going to vanish when the procedure finishes, and exactly how that works you'll learn how to do in assembly. Learn how that actually operates. But they're going to go away. So the primary difference between these local variables and these instance variables is that these stay around until the object gets garbage collected. Okay? They're there taking up space, but they're latest values until the thing gets garbage collected. We don't have to do any garbage collection for the local variables. That happens automatically. It's the way the procedure calls work. So you're not going to garbage collect local variables. The way this thing gets translated into assembly, that's going to happen automatically. But not these things. Okay? They have to be specially garbage collected when nobody is pointing to this particular object anymore. The 2 and the 3 will eventually be reclaimed by memory. Okay? All right.
Question about garbage collection.
Yes.
Will that happen only while a process is running, or will that happen passively when nothing is running?
I would imagine that the interpreter tries to be intelligent about when it runs the garbage collector and tries to find good places for it, but I don't really know. It is, in general, going to slow down your program because every once in a while we're going to look through memory and see if anything's been stranded.
Okay, so if you force quit the program, it's not going to garbage collect?
That's a different, so the operating system will grab everything, okay, when you force quit.
Okay.
So the garbage collector doesn't run, but it does get reclaimed.
Okay.
So whatever the operating system gave to your program, it's going to grab all that back. Okay? All right. So we finished the constructor. So I've got some other constructors in here. Okay, I'm going to skip them right now. Let's do something more important. I like to do multiply. Okay? So there's a lot of interesting stuff in here about multiply. So let me go ahead, before I try to dive into that procedure, let's go ahead and try to call it from our driver. Okay, so we can look at the documentation for this class, which hopefully is online somewhere. Okay, or if we have access to the source code, we can simply look at the method signature and let's copy and paste that so we know how to call this thing. First of all, it's public, so I can call it. If that procedure had been private, I can't call it from rational driver. Okay? But since it's public, I can. And it looks like we're going to be multiplying two numbers together. We got to figure out which two numbers we're multiplying together. Okay? So, and then it returns a rational number. So something like this. In fact, let's make that be 1. Something like this, we'll call that procedure. And I figured that out from the method signature here because I know in object-oriented languages, objects call methods. Okay? So that means I need to pick one of my rational numbers and call its multiply method. Then I'm also supposed to pass one in there. So that's how I get the two rational numbers in this procedure. I have one that's calling the method itself, rn3, and I have the other one that I pass in there. So presumably rn3 and rn1 are going to be multiplied together. Okay? rn3, because we made this class be immutable, rn3's numerator and denominator are not going to be changed. Rn1's numerator and denominator are not going to be changed. I'm simply going to create a new rational number with the correct new numerator and denominator in them that corresponds to the multiplication and return that rational number. So that's how we make it immutable. When we ever want to do an add, a multiply, a subtract, divide, whatever the case may be, make sure that within the procedure, to represent the result of that computation, you're just creating a brand new object and returning it without ever disturbing the variables for the two involved in the operation. Now, as I said, sometimes that's just super inconvenient. Sometimes it really makes sense to go ahead and change the values of one of the objects. In that case, you probably need to document that that's going on. But for rational numbers, that would be silly to do. It's very easy to make it immutable. It's much easier to debug things that are immutable. Okay, so let's go back and look at it. Okay, so I'm computing the new numerator. Notice that it's local. I'm not overriding that thing. I created a new local variable called numer. That's going to be the result of multiplying the two numerators together. Okay, so what on earth is going on here? So another way I could write this. By the way, what do you think get numerator does?
Just the denominator?
Yeah, get numerator returns the numerator, get denominator returns the denominator. Okay, so again, because, okay, this is important. Now you might think, looking at this, well, I'm giving my user access to the numerator, and so now they're going to be able to change it. So suppose that let's go back to our driver class. Here. Okay? This will do nothing bad to my object, because when you return, remember pointers and primitives, when you return primitives, you're returning an actual value. Okay? So I get a new copy of what the denominator used to be, then I change its values, which is going to not affect at all what Rn4's actual numerator was. Okay? That's not the case with pointers. With pointers, you can get into trouble giving users access to stuff, to objects that they can then change values of. But for primitives, you never have to worry about messing up the contents of your objects, because you're always getting copies. Okay? So that's going to work okay. All right. So numerator times. So another way we could have done that computation is like this. Okay? I ask other rational for its numerator. I directly access my numerator. Whose numerator is that? If this is my statement. You got two possible objects. It could be Rn3's numerator, it could be Rn1's numerator. What do you suppose I'm calling Rn1 inside that procedure? Who's Rn1 in here?
Other rational?
Other rational is Rn1. In fact, it seems to me we need to draw a picture. There was some hesitation there. Okay. So we got Rn1 and its stuff. We've got Rn3 and its stuff. And we're trying to create Rn4. Okay? So when I call that procedure Rn3.multiply Rn1, I'm going to create some local variables. I'm going to create a local variable called other rational. Okay? So you might have called something like this pass by copy, but I like to think of everything, pass by reference. I like to think of everything as pass by copy. The difference being, what is it that you're copying in there? Okay? We are going to copy, in order to pass that local variable in there, what we're going to do is copy the contents of Rn1 into other rational. Okay? What happens when I copy the contents of a pointer into some other location? Where's our other rational going to point? The same place that Rn1 points, because they have the same memory address. That's super important, and it looks like maybe that doesn't make a lot of sense. Okay? When you make a copy of primitives, you're creating a brand new variable. A equals 10, B equals A. You've got somewhere A's literally holding 10, and somewhere B's a brand new variable holding 10 as well. Okay? So that's copying the value. That doesn't, with pointers, you got to remember that you're dealing with memory addresses, not actual values. So when I copy the contents of Rn1 into other rational, my picture looks like this. Okay? So if I make any changes, now if I make some, well, we'll get to that in a second. But that's important. So you won't hear me talking about pass by reference much. Okay? I'll say pass by copy. In fact, what I'll say is we're creating an alias. There's your first funny term. An alias is when two pointers point to the same, two or more, you can have multiple aliases, two or more pointers point to the same location in memory, i.e. they have the same memory address stored at that pointer value. Okay? All right. So back to our procedure, somewhere here. So I created it. It's essentially the same. I have a pointer to Rn1. I've just called it a different name. Okay? So now I can pull out its numerator, and I can multiply it by whose numerator? In that case, when you just have a variable sitting there like that, what we're talking about is the calling object's variable. Okay? So even though we made numerator private, we're inside a method of that class. So we're allowed to access that variable now. We just don't want outside users to directly access it. It's not a problem for us to access it. So this is the calling object's numerator. They get multiplied together. And before I leave, I'm going to create a new rational number with the result of that multiplied together numerator. And I'm going to do the same thing with the denominator. Okay, I'm going to multiply the two denominators together, put them into the new rational number, and return it. Okay? More stuff to discuss here. Generally, I don't like to see this in your code. There's really nothing wrong with it. You're allowed to access private variables if you're inside a method of that particular object. But in fact, we're allowed to do this as well. Okay? So unfortunately, private does have a loophole. Using the keyword private doesn't protect us completely. If we're talking about all the objects of the same class, Rn1 and Rn3 and other rational are all rational numbers, they're allowed to access each other's private data. Okay? So that will not be a question on the test. In fact, I'm hoping that I never see you actually do that beyond today's lecture. Okay? So technically you can, but let's get into the habit of not doing that unless trying to come up with some other procedure for doing whatever it is we need to do gets extremely complicated. So I want to say, don't reference it directly. Use the get methods. Okay, ask other rational for its numerator, and I've got it there. Okay? Furthermore, I can do the same thing here. Oops. If I don't provide an object, it's assumed we're talking about the calling object, which is what I want. I want Rn3's numerator to be multiplied by other rational's numerator, which, oh, by the way, better be R1's. And it is, because other rational points to the same location that Rn1 points to. Okay? All right. Let's see, back here. One more thing I need to show you here. Another way of saying I want to call the calling object's get numerator method is to use the keyword this. So this is that automatically, so generally speaking, we like to always follow the rule of object.method. Okay? So probably most of the time you'll see me try to remember to do it that way. But if I leave that off, Java will insert it for me. Okay, so technically all method calls have to have an object. If I leave one off, this dot is going to be supplied for me. Okay, so I'll go ahead and put that one to this dot. So notice denominator did the same, didn't have it there. That's equivalent. Okay, so now it looks like the way I kind of wanted it to look. Okay? All right, now what happens at the end of the method?
Wait, in this case, what
Yes.
is this referring to?
This is referring to the calling object, which we actually have to look back at the driver, is R3.
Okay.
Okay, so that would be R3's numerator and denominator. Other rational refers to R1's numerator and denominator. So I am, in fact, getting the correct stuff multiplied by the other stuff. Okay? All right. So back inside the method, when this thing finishes, what happens to other rational? As you guys told me just a few minutes ago. Is it a local variable? It's a parameter, it's a local variable. What happens at the end of the method?
It's deleted.
It goes away, which in our diagram simply means that that's gone. Does that mean that my rational number is going to be garbage collected? No, because my driver still has a reference to Rn1. Okay? In fact, I want those local variables to go away. I don't want this proliferation of variables. So as soon as the method completes, there's this cleanup of all the local variables. Stuff I declared in there, plus any of the parameters. Okay? And we're not going to lose the object because it's still got a reference to it. So if the garbage collector does run, it's going to say, oh, this 2/3, Rn1 still points to it, so I better leave it alone. Okay. Now, go back to the code for a second. The next thing I need to cover is the fact that you can do this. So let me comment this, let me rewrite this line. This is perfectly legal. There's nothing wrong with me saying Rn3 multiply Rn1. Okay? My method will run. I will create a new object. I will return that memory address. The memory address of the object I created does not get stored anywhere. What happens to my work? It gets garbage collected. Okay? So I know I'm going to see a lot of that on exams and programs. I'm just used to it. It would be kind of nice if you got a warning or something. Okay? Because maybe that's what you meant to do for some reason, but probably it's not. So, but it will just compile, and you won't have that answer stored anywhere. So you have to remember that if the method returns something, most likely 99.9% of the time you're going to want to store whatever's coming back in a variable. Okay? Now, if we had written this class real sloppily and we made it be not immutable, to where I changed the values of Rn3. So let's say we did that. Let's say we rewrote this method and we actually changed down here numerator to be numer and denominator to be denom. Okay, rather than creating a new object, we just manually set our instance variables to be those new values. Well, then we don't need to return anything. So a method that doesn't return anything is void, and now that would be correct. Okay, I did not lose my work because I changed the instance variables inside Rn3. The method doesn't need to return anything in that case, so that's appropriate. If the method is void, you don't want to store, there's nothing being returned, so you don't want to store anything. You will get a compiler if you try to do that. Okay? But the opposite is not true, because there are a few extremely rare cases where you don't want to store the return value. Okay? But it's extremely rare. So we do want to store the return value. We're going to store it in a new rational number, R4. So in our diagram, we would be getting a new one back. Okay, we return it from our procedure. We copy the memory address into R4's variable, which means now it points to that new thing. Okay? Next, what if we didn't really want to create a new variable? What I really wanted to do is, even though I know the procedure is immutable, I don't really need an Rn4. I really just kind of want Rn3 to move to the new one, okay, and not have a brand new variable declared. Is there any way for me to do that? And if so, how do I do it? So hint, hint, the answer is yes, there's a way to do it. How would I change this line? Okay.
Similar objects can access each other's private variables.
It's simpler than that. Okay, here's how you do it. If I really don't want to declare a new variable, let's not declare a new variable. Okay, I just want Rn3 to be the result. Okay, how is that going to work in our diagram? So there's no Rn4. That's gone. We don't need A and B anymore. Okay, I return a memory address. It gets copied into Rn3. How does Rn3's picture change? Points to that one and not that one. What happens here? Garbage collected eventually. Okay. Actually, our program's going to quit before it gets garbage collected, but let's pretend.
Does Rn3 point to both its numerator and its denominator, or are those both stored in separate places?
Okay, Rn3 points to the memory location where both variables are stored together.
So when you first change just the numerator after multiplying, it'll get put into a new memory address with the same denominator and a new numerator, and then it'll do it again with the denominator. So you would actually create.
So I'm creating well, that's represented in our diagram by the fact that I've got a brand new box down here. So I did now create a new numerator variable, put a value in it. I created a new denominator variable, put a value in it. And now I'm pointing Rn3 to those new numbers. If I don't need the old ones anymore, then this will accomplish. Rn3 essentially gets updated with the new values by pointing to a brand new object. And then the old one, now nothing points to it anymore, so it gets garbage collected. So if I didn't need the old result anymore, and I'm trying to deal with immutable objects, this is how you can do it. Okay, just let it be garbage collected, rather than messing with delete like you had to in C++. I'm not sure I answered your question.
The question was, would it do it all in one fell swoop, or would it change the numerator, make a new memory address, and then change the denominator and make another one?
Okay, the way that would happen is here is where I would be creating the space for the new numerator denominator. Anything else? Good question. Okay. Let's see, 4:15. Are we done with this? Let's see if there's anything else interesting in here. I don't want to talk about equals yet. What's toString supposed to do? Yes, it provides a string representation of the instance variables for that object. Primarily, that's useful for purposes of debugging. You want to see what's going on in the object, make sure the numerator and denominator are what you expect, call a toString method. And make sure your toString method then prints out the contents of those numerator and denominator. Now, I've got some whole number stuff that's happening in here. So there's a lot of work in here. Normally two strings don't look this complicated. Okay. Now reduce is private. Okay. You are allowed to make methods be private if you don't expect outside users to call it. So the way that we handled that is when the constructor got run, which is, by the way, is public, so we can call the constructor, the last thing the constructor does is calls that private method. So the numerator, the fraction will be reduced, but I want to control when that happens. I want it to happen here in the constructor. I don't want other people to be able to call that reduce method. Okay, because actually, presumably, since it's an immutable object, after we've done it here, it doesn't need to be done anymore anyway. Okay? If they create a new object, then that new object's constructor would call reduce and so forth. So it makes sense to make that be private. And reduce calls another method GCD, which, by the way, is also going to be private. Okay? All right. I think that's enough on rational numbers. Let's now talk about file I/O. Okay, so I've mentioned, oh boy, here we go, the facade design pattern. Does anybody remember what that is? The name of it's kind of a big hint.
It's like something that goes over something else and kind of makes what it actually does easier.
Yes, that's exactly right. So what I've done, again, if we use the built-in Java classes for reading and writing files, there's a lot of concepts that we would have to jump into from the beginning that I would basically say, just ignore this, ignore that, ignore that. So instead of doing it like that, just like for the keyboard class, I would have had to do that for scanner. So I hid scanner inside keyboard, and I've also written the file I/O classes inside classes that I've written. So that's abstraction, and that's the facade design pattern. Okay? We're putting a nice clean face on what otherwise would be a lot more complicated looking. And it would make difficult for us to do file I/O here at the beginning of the course because there's a bunch of stuff we haven't covered about Java yet that I would have to either tell you to ignore or try to cover it. Okay? And it's too early for that. All right. So, to that end, we've got some files in the util package. So I need to import them, and I'm pretty sure I did here at the top of the driver. Read text file and write text file. So these are targeted towards reading text files as opposed to binary files. So we're assuming the contents of the files. We read a byte. We use the ASCII code to figure out what the character is supposed to be. That's the character. Okay? That's different than, a binary file where it could be an image or something else. So the vast majority of stuff we do at the beginning of the class are just text file processing. So I've geared these towards those types of files. Okay? All right, let's see what we have available inside those files. I'm pretty sure that these are for one of the labs. You can download all these files, and I'm pretty somewhere in there I've got them documented. Or at least I've got the method signatures listed so you can find them without having to look at the source file. But let's go ahead and look at the source file. Okay? All I care about, I don't care about this try-catch stuff. That's what I'm trying to save you, to hide from you. But I do care about this part of the method signature. Okay? I'm just going to provide a file name. If the file name's not there, then yeah, bad stuff might happen, but let's assume that the file's going to be there. Okay? Then I have an end-of-file procedure that tells me whether I've reached the end of the file. And the only other thing I need to care about is read line. So we only need 3 method signatures. A constructor, which obviously, an obvious thing for me to do is have it take a file name. You give me a file name, I'm going to try to read text from that file. I need to ask, after I read a line of text, have I reached the end of the file? Yes or no? That's a Boolean. And then finally, okay, I haven't reached the end of the file. Give me the entire next line of text, and I'll copy it into a string and return it. Okay? So if we want to read some, I've got an input file set up here somewhere. Resources. So I've got an RN text file which reads in a bunch of rational numbers. I want to read them in and then print them out again, and hopefully I get a match between the two. Okay? So, how are we going to read in? Let's hide some stuff here. Let's read in our file. Well, we saw that there's a constructor, RTF, that takes a string that corresponds to the location of the text file. And I've already forgotten what the name of it is. rn_in.txt, and it's in the resources directory, _in.txt. As long as the file is there, you don't have to worry about that other complicated stuff. Okay? Now, I need to see if I've reached the end of the file. Here's a tricky thing that's going to occur pretty soon in lab. We start doing this a bunch in lab. We start reading in from text files. Okay? I'm not sure if it's 2 or 3 or 4, but soon we're going to be doing this kind of stuff. And I can tell you, I know it's going to happen because it's happened every single semester. You forget the next step. You try to check to see if you're at the end of the file before you be tempted to read anything. So all we've done is open the file. We have not made an attempt to, we don't even know what the first line is. We haven't accessed any of the characters yet. So the first thing I have to do is attempt to read before I can tell whether I reached the end of the file. It could be an empty file. Okay? Text is equal to RTF. So remember, we got to use our correct conventions for calling those procedures. And the read line, this part anyway, I need an object to call the read line method, which takes no parameters, and it's going to return a string which I better store somewhere. So remember, 99.9% of the time, if it returns something, you probably want to store it in a variable. Okay? So I followed those rules. I've got a calling object, which is the thing that I created up here. Okay, by the way, we could have done this instead. We don't have to call the constructor. You guys remember null from C++? What does that mean? Okay, the pointer doesn't point to anything. In C++, it's literally a 0. Okay, Java has another mechanism. We make the pointer be null. Okay? So if I do this, it's going to compile just fine. Do you think it's going to run just fine? No. Okay, so you're going to see this a lot, so it's worth me mentioning now. You're going to get, if you accidentally make this mistake and you have a pointer that doesn't point to anything and you try to call a method on it, that is a null pointer exception. Okay? At first, you're going to be really scared of these. But by the end of the course, you're going to realize this is one of the, you don't mind these. These are actually one of the easy ones to fix. So you know what it is. Somewhere I have an object that have a pointer that doesn't point to an object, and I tried to call a method on it. They're actually really easy to find once you get past being scared of them. Okay? So in this case, it's pretty clear that what my problem is. I need to change that around. And now that I have a line of text, I can test to see whether I've reached the end of the file. While not rtf.eof, I keep wanting to use an arrow. Okay, by the way, no arrows in Java. The dot in Java corresponds to an arrow in C++. Okay, so I'm dereferencing these pointers when I use a dot. Okay? So while it's not the end of the file, let's print out what the text was. And then let's get the next line. It's as simple as that. And then it's also a good idea to close the file. So the tricky thing here, to use these correctly, you need to access some characters first to determine whether the file is empty or not. So if it's empty right off the bat, I won't do anything. Okay? Nothing will print out. I'll just close. I open the file, now I'm going to close it. That's all that would happen. But if it's got a bunch of stuff in it, well, that's fine. All those lines will print out. Let's see if that actually happens. Okay, I don't know what the -1/9 is. Something we did up there. Oh yeah, with RN3 maybe. Okay, but once we get, that's, okay, so that's probably what got printed out here. That's right, I put in a negative, didn't I? Yeah, I did. Okay. But the other stuff looks fine. That looks like the stuff that we had in our file. Okay? Let's write our contents out to an output file, which I'll go in here and delete that one. And we'll use write text file to write it out. That'll be the last thing we do. Oh boy. No, that's not going to work. Okay. I didn't store those values somewhere. I think what I want to do, before we do that, maybe we'll have to pick this up on next Wednesday. I don't think we have time to finish it. But what I want to do instead of is actually like to put this stuff in a collection. And we have a collection that we can use. So as I'm reading the items in, and it looks like we got them all correctly, I want to put them in one of these guys. Okay? And then, once they've all been stored in the collection, I want to iterate over the contents of the collection and write it to the output file. Okay, so let's see. Let's create a rational number. We got a couple of minutes. Okay. One of my constructors will actually accept text. And the reason why I put that constructor in there is so that I can do this exercise. So I'm reading in 1 divided by 2 or 2 divided by 3. If I pass that to the constructor, that text, it'll parse it, find the numerator and denominator for me. Okay? So you can have multiple constructors, as I'm sure you guys remember from C++. And then I need to add it to rats. And let's make sure that that actually executes. Oh, I get a null pointer exception. Okay. We printed text. Oh, yeah, I see how that happened. Okay, what did I do wrong here? Yeah, I've got a pretty serious mistake here. This needs to be after I've done all the processing on the current one. Okay, so I was advancing, when I got to the end of the file, I was advancing to the next one, which there isn't one, and then it crashed. So that should look like that. Okay, good enough for today. Have a good weekend.